Welcome to Section 5, Topic 8. You are more than welcome to watch this in Math Nation if you prefer. Wasn't sure if I was going to be able to Zoom and record today, and this is kind of a heavy section, and also wanted to let you know that I think the homework is a little bit easier than what the section is showing. Anyway, so let's talk about an isosceles triangle and the properties of it and the base angles theorem. All right, so by definition, an isosceles triangle is a triangle with two equal sides. Okay, so you have two equal or two congruent sides, then you have an isosceles triangle. So let's look at the triangle that we have below, UVA. And the information, the only information that's given in this triangle at this point in time is the fact that we have these two congruent marks right there. Therefore, we know it's an isosceles triangle based on the definition of it. It says, let's draw the angle bisector segment VP of angle V. Before we get into that, I want you to be able to know the parts of an isosceles triangle. So we have the vertex angle, which is going to be across from the base of the triangle. So this is the base. UA is the base. We have the two legs. So this is a leg. This is a leg. And then these are called base angles. Okay, so you have your vertex angle, then you have your two base angles. All right, so what we're going to do, let me go ahead and erase this middle part here so we can see it. It says draw the angle bisector VP of angle V. So if I were to draw an angle bisector, I'm going to go to V, and we can do a construction on this once we are able to do that. And if I drop the angle bisector, it's going to hit the base, and it's going to create two angles. Okay, and because it's bisecting it, it's cutting it into two congruent parts. All right, so I'm going to name this P. Okay, it says use paragraph proofs to show that the measure of angle U is equal to the measure of angle A in two different ways. We're going to do one way as a transformation. We're going to do the other way as triangle congruence postulates, meaning our side angle side and all of that. So let's think about the transformation first. We know that transformations, if there's any way that we can do a rigid motion and it maps on top of the pre-image, then we know that they are congruent. So what kind of transformation, a rotation, a translation, or a reflection, is going to map angle U onto angle A? Hopefully you see that if I do a reflection across segment VP, that angle U is going to map onto angle A. But we have to be a little bit more specific. So we are going to reflect triangle VUP. Notice what I did there. VUP is the left triangle that we just created. Okay, so VUP, VUP. That triangle right there is what I'm talking about. So I'm going to reflect that triangle across our segment, VP, and it will map onto triangle. Make sure that when we're saying maps, think about it folding over. It's going to map angle, and it will map onto triangle VAP, V will map onto V, U will map onto A, and P stays where it is. So what does that mean? Thus, angle U will be mapped onto angle A. Okay, but the proof says what we have to do is not show congruence, but we need to show that the measures are equal. Okay, well, one thing that we know, we're going to bring this up, the definition of congruence says that if two parts are congruent to each other, then their measures are equal. So the measure of angle U is equal to the measure of angle A. And if you want to think about it, definition of congruence. We're going to say that in the right-hand side where we're showing our triangle congruence postulates. Okay. So in order, I'm going to let you finish writing that really quickly, but I'm just going to kind of talk it through. For the next part where we're thinking of our statements and our reasons, our traditional two-column proof, we are trying to prove that the measure of angle U is congruent to the measure of angle A. Notice that when we had the angle bisector VP, it created two smaller triangles. So if we can prove that those two triangles are congruent, then we know that the corresponding angles are also going to be congruent. So hopefully you've had a chance to finish that up, and let's take a look. All right. So the given information, remember at the beginning of this, I said that they gave us some information. They gave us, based off of the congruency marks, that VA is congruent to VU. And I'm going to write that backwards because I should have done that. I should have said, I'll get myself all messed up if I do it the opposite way. About to do it again. VU is congruent to segment VA. And the reason for that is that it is given. Okay. Now, when we constructed that angle bisector VP, it created segment VP. So we know that VP is congruent to segment VP because of the property that means common in both triangles, reflexive. The reflexive property of congruence. So I'm going to go ahead and mark that. Okay. So I've got a side and another side. And what happened, what did that angle bisector create? It created congruent angles. So let's name those congruent angles. I'm going to name the first angle UVP. And it's going to be congruent to angle AVP. I had to make sure that my corresponding vertices are all lined up. And I know that those are congruent because that is the definition of an angle bisector. Okay. So now I have enough information to prove that those two triangles are congruent. Those two triangles are congruent, so triangle VUP is congruent to triangle VAP because of side angles side. So let's go back up here and see what we've got. We've got a side, an angle, and a side. On the other side, side, angle, side. Okay, so that's where that information is coming from. So I know that those two triangles are congruent. What I'm trying to prove is that this angle is congruent to this angle. Actually, that the measure of angle U is equal to the measure of angle A. So we've got something that is called CPCTC. So let me just write that down. You're going to see it a lot. CPCTC. What it means, if I have corresponding parts of congruent triangles, then they are congruent. So angle U corresponds to angle A. Okay, so they are corresponding parts. They are in congruent triangles. Therefore, they must be congruent to each other. Okay, so what I know is that angle U is congruent to angle A because they are corresponding angles or corresponding parts in two congruent triangles, so therefore they must be congruent. Corresponding parts of congruent triangles must be congruent. I'm not done because it doesn't ask us to prove that the two angles are congruent. It says prove that the measures are equal. So I'm going to write the same statement that I had here, that the measure of angle U is equal to the measure of angle A. That is the definition of congruence. Okay. Congruent angles have equal measures. Things that are congruent have equal measures. Now, one of the things I would do is I would either rewind this and listen to it again, or just kind of take it slow as you're walking through these particular proofs and theorems. Okay. All right, over here. I'm not going to go through all of these because it's a little too much for the brain, and you don't have the ability to color in like I do, but for each of the following congruent statements, name the isosceles triangle and the pair of congruent angles for the triangle based on the diagram above. So if I'm looking for CD, here's CD, and BD. Okay, here's the other part of BD. So it's saying that those two pieces are congruent to each other, so therefore I know I have an isosceles triangle. All right, here's the base right here. So that means the base angles would be here and here. All right, so I'm going to kind of ignore everything except for that triangle, and I'm going to say, let's name that triangle. I'm going to name it triangle BCD. You can name it with any three vertices there. But the two base angles are angle B, and it is going to be congruent to angle C. All right. Let's look at, I'm not going to do all of these. Let's look at D. Okay, D, let's see, we're looking for EJ. And it is congruent to FJ. There's your two congruent sides. Okay, so that means that my base is FE, and that means that this angle should be congruent to that angle, your base angles. So, named a triangle, let's name it FEG, FEJ, all right, and your angles, angle F is congruent to angle E, or angle E is congruent to angle F. Do you see a pattern emerging yet? If not, let's try one more. Let's try FB is congruent to GB. So FB is congruent to GB. I don't know how you could do this without colored pens. All right, so we've got this and we've got this. So that means that this is our base of our isosceles triangle. This is our base angles. So if I were to name that triangle, I'm going to name it triangle FBG. Okay, and my base angles that are congruent to each other, or angle F, is congruent to angle G. Do you see what's happening? Have you picked up on the pattern yet? Okay, what the pattern is that your base angles or that first letter there. Okay, that's pretty much it. All right, so here is what we're taking away with this unit. The base angles theorem and its converse. Remember, converse is just the opposite way around. The base angle theorem states that if two sides, so if we know two sides are congruent, then the angles opposite these sides are also congruent. So let me show you what I mean. Okay, they're telling me that two sides are congruent, then the opposite angles to these sides are also congruent. The converse of that says if they give us the angles first, then the opposite sides are congruent. All right, so the converse is if they give us the angles first. This is just like when we had parallel lines. If we knew the lines were parallel, then the angles were congruent. But if they told us the angles were parallel, then it was the converse. All right, so if they're giving us the angles, it's the converse, just like in that prior proof that we had before, or prior theorem. All right, so now let's kind of put this together and look at this figure of several triangles, and we're trying to prove that side CR is equal to CE. So we're trying to prove that this is congruent to this. So in order to do that, first thing I know, I can already tell that they're not giving me angles first, so it's going to be the converse. So keep that in mind. It's going to be the converse. Also, before I look at the statements and reasons, I want to mark up everything that it tells me. So mark up what I can. So it's saying given triangle REA, so that's the big triangle. DC is the angle bisector of RCA. Okay, so here's RCA. So DC bisects that angle. So that means that this is congruent to this. That's what an angle bisector does. Then it's telling me that RE is parallel to DC. Okay, so parallel lines, do I have a transversal there? Yeah, I have a transversal here. So if I have a transversal there, does it give me any alternate interior angles? No, but it does give me a corresponding angle. So look what I mean by that. This angle right here, I'm going to put it in blue, corresponds to this angle right here. Okay. I also have a transversal on those parallel lines that goes this direction, R to C. Okay. And I have another set, and I'm going to mark it in the same color because they're all congruent. This one right here is congruent to this here because of alternate interior angles. So do you see that I have 4 angles that are congruent to each other? I hope that you do. All right, so now let's go through, and again, what we're trying to prove is that this is congruent to this. All right, so you see those base angles down there? That's going to help us out. Okay, so let's go ahead and get back to it. We have our given, and now we're trying to prove that our two base angle, or we're trying to prove that angle DCR is congruent to angle ERC. So DCR and ERC, that is going to be this angle here and this angle here. Okay, so those are alternate interior angles are congruent. Okay, and then the next step is the corresponding, and we saw the corresponding. So those corresponding would be this one right here and that one right there. So let's name those angles, and we're going to name them with 3 letters just because I can name the top one angle E, but I'd have to name the bottom one with 3 letters, and everything else is named with 3 letters, so I'm going to stick with it. So I'm just going to say that this is angle DCA, oops, that didn't work. Angle DCA, that's the bottom one, is congruent to angle DCR because of corresponding angles theorem. Okay. Now, I also know that DCA is congruent to DCR. I'm trying to find those. Okay, I saw them. Sorry, had to look for them. So let me highlight those in case you were having the same issue that I am. DCA, and right there, that is going to be the definition of an angle bisector. Okay, so we've got 4 of these angles, and they're represented 3 different times. So if I use the transitive property, so write small on this, trying to give you a heads up. If I use the transitive property, I'm going to be showing that all 4 of those angles are congruent to each other. So I have angle REC that's congruent to angle ERC that's congruent to angle DCR that's congruent to angle DCA by the transitive property. Actually, I think I probably could have written down just that measure of angle or just angle of REC is congruent to the measure of ERC, because what I'm trying to show is that these 2 sides are equal to each other. Math Nation did do it with all 4 of those in there, but I think I probably could have cut it down to just those 2. And then what I say is that I know that those are congruent to each other, therefore I know that their measures are equal to each other. So the measure of REC is equal to the measure of angle ERC. And what does the definition of congruence mean? That those measures are going to be equal to each other if they're congruent. All right. Then the last step is that I know that CR is equal to CE, because if the angles are congruent to each other, then based off of the converse of base angle theorem, then those sides are going to be equal to each other. Okay, ready to go to the last problem? Okay. All right, we've got 2 triangles here. We've got triangle PMN, we've got triangle PQR. The very first thing that it says is it's saying that the giant triangle, if we're looking at PQR, is showing that PQ is equal to PR. So if those are equal, then we know that we are dealing with an isosceles triangle. We are trying to prove that PM is congruent to PN. Okay, so we're trying to prove that the sides are congruent. So again, we're going to be talking about the converse. Okay, so we know that the giant triangle, the 2 legs are congruent. So the triangle is an isosceles. That is simply the definition of an isosceles triangle. Okay, looking just at the big triangle, an isosceles triangle, if those 2 sides are congruent, then their opposite base angles are also congruent. That's what the base angles theorem says. So what I know is that angle QRP, that is this angle right here, QRP is congruent to angle RQP, this angle right here. That is the base angles theorem. If the sides are congruent, then the base angles are congruent. And we're trying to do the same thing with this one up here. All right, says that we have parallel lines. So when we have parallel lines, that must mean that we either have corresponding angles or we have alternate interior angles. Well, I don't have any alternate interior angles going on, but I do have this angle right here, let me mark it in green. This angle right here is going to be corresponding to this angle right here. So that means this angle here is going to correspond to this angle here. Okay, so it says angle NMP, NMP. So again, this angle right here is congruent to RQP, this angle right here, and MNP, this angle right here, is congruent to QRP, that angle right there, okay? And the reason for that is that they are corresponding. Okay, so now it's showing transitive properties. So what I'm trying to do is I'm trying to prove that that triangle is an isosceles, or that I'm trying to prove that the sides are congruent. I know that the base angles are there, so I'm going to eradicate or eliminate the QRP. So QRP is congruent to RQP, so QRP is congruent to MNP. So the angle MNP is congruent. All right, this one corresponds with that. So angle NMP for the transitive property. Okay, and if those two angles are congruent, by the definition of congruence, then their measures are equal. We do have to include that in there. All right, so now that I've proved that those measures are equal, by the converse of the base angles, then I know that their sides must be equal to each other. All right, and that is pretty much it. I feel like this is a little too confusing. I don't want to get into it too much, but if you want to ask me about it, let's see, you can kind of go through it yourself, but here they're wrong here. This is the converse again. We're not using a perpendicular bisector, we're using an angle bisector. So anyway, that's part of the problems with that one over there. I don't want to make this extremely too long for you, but I'm going to stop there. Again, feel free to watch this on Math Nation if you would prefer, and have a great day.